Section 26 of Sun, Moon, and Stars, Astronomy for Beginners. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Read by Bill Welch. Sun, Moon, and Stars, Astronomy for Beginners, by Agnes Giberne. The Milky Way. Who knoweth not in all these that the hand of the Lord hath wrought this? Job 12, line 9. One star differeth from another star in glory. Corinthians 15, line 41. The Milky Way forms a soft band of light round the whole heavens. In the southern hemisphere, as in the northern hemisphere, it is to be seen. In some parts the band narrows, in some parts it widens. Here it divides into two branches. There we find dark spaces in its midst. One such space, in the south, is to the naked eye so black and almost starless as to have been named the coal sack. But photography shows abundance of stars to lie there also. All along over the background of soft dim light lies a scattering of brighter stars shining on its surface. Much interest and curiosity have long been felt about this mysterious Milky Way. That it consists of innumerable suns, and that our sun is one among them, has been believed for a considerable time. But other questions arise. How many stars does the Milky Way contain? What is its shape? How far does it reach? No harm in asking the questions. Only we have to be satisfied in astronomy to ask many questions which cannot yet receive answers. No harm for man to learn that the utmost reach of his intellect must fall short in any attempt to sound the depths of the universe. Even as the arm of a child would fall short in seeking to sound the depths of the ocean over the side of a little boat. For attempts have been made to sound the depths of our star galaxy out of this little earth boat. The idea first occurred to the great Herschel, and a grand idea it was, only a hopeless one. He turned his powerful telescope north, south, east, west. He counted the stars visible at one time in this, in that, in the other directions. He found a marked difference in the numbers. The portions of sky seen through his telescope was about 1/4 the size of that covered by the moon. Sometimes he could merely perceive 2 or 3 bright points on a black background. At other times, the field of his telescope was crowded. In the fuller portions of the Milky Way, he had 400 or 500 stars under view at once. In one place he saw about 116,000 stars pass before him in a single quarter of an hour. Herschel took it for granted that the stars of the Milky Way, uncountable in numbers, are as a rule much the same in size. So the brightest stars would, as a rule, be nearest, and dimmest stars would, as a rule, be furthest off. Where he found stars clustering thickly, beyond his power to penetrate, he believed that the Milky Way reached very far in that direction. Where he found black space, unlighted by stars or lighted by few stars, he decided that he had found the borders of our galaxy in that direction. Following these rules, which he had laid down, he made a sort of rough sketch of what he supposed might be the shape of the Milky Way. He thought it was somewhat flat, extending to a good distance breadthwise and a much greater distance lengthwise, and he placed our sun not far from the middle. This imagined shape of the Milky Way is called the cloven disk theory. To explain the appearance of the Milky Way in the sky, Herschel supposed it to be a cloven or split through half of its length, with a black space between the two split parts. It seems that Herschel did not hold strongly to this idea in later years, and the rules on which he formed it no longer hold good. For how do we know that the stars of the Milky Way are, as a rule, much the same in size? Certainly the planets of the solar system are very far from being uniform, and the few stars whose weight can with any certainty be measured seem to vary considerably. There is a great difference also between the large and small suns in many of the double stars. Again, although bright stars undoubtedly are as a rule the nearest and dim stars furthest off, there are many exceptions. Look at Sirius and 61 Cygni. Sirius, the most radiant star in the heavens, and 61 Cygni, almost invisible to the naked eye. According to this rule, 61 Cygni ought to lie at an enormous distance beyond Sirius. Yet, in actual fact, Sirius is the further away of the two. For, aught we know, there may be many small telescopic stars much nearer to us than many of the brighter stars which we can plainly see with the naked eye, and only invisible without the help of the telescope because of their smallness, not so much because of their distance. This line of reasoning shows how easily mistakes may have been made in a matter of no slight importance. Some chapters back I spoke of the light traveling to us from far distant stars, stars so distant that their light must have taken thousands of years to reach us. Only there is no must. We do not actually know the fact. A writer says, the illustrious Herschel penetrated on one occasion into this spot, the star cluster of the sword hand in the constellation of Perseus, until he found himself among the depths whose light could not have reached him in less than 4,000 years. So Herschel believed, but he did not know. There is no certain could not in the matter. The distance of those stars had not and has not been mathematically measured. Herschel judged of it by their dimness, by the strong power needed to make them visible, and by the rules which he had adopted as most likely true. This was no sure mode of judging. The stars might be as far distant as he supposed. On the other hand, they might be very much nearer. If too far for our measuring line to reach them, they may be only just too far, and their seeming smallness and dimness, instead of being caused by vast reaches of space between, may simply be caused by actual smallness or actual dimness. There are little suns as well as great suns in the Milky Way. It is possible that hundreds of little suns may exist for every single specimen of a great sun. Again, when Herschel found black spaces in the heavens, almost void of stars, and believed that he had reached the outside borders of the Milky Way, he might be right, or he might be mistaken. The limit might lie there, or thousands more of small stars might extend in that very direction, too far off for their little glimmer to be seen through the most powerful telescope. A good deal of attention has been paid to the arrangement of stars in the skies. The more the matter is looked into, the more it appears that stars are neither regular in size nor regular in distribution. It would seem that they are not flung broadcast through the heavens, each one alone and independent of the rest. They are placed often, as they have already seen, in pairs, in triplets, in quartets, in clusters. Also, the great masses of them in the heavens seem to be more or less arranged in streams, in sprays, in spirals. It should, however, be understood that what may look to us like streams or spirals may in reality be nothing of the kind. Distance is very deceptive. Even on Earth, any object far off may appear to be close to another object from which it is really separated by many miles. And if this is so on our little Earth, how much more easily may one be mistaken in celestial landscapes? We must now try to form a few clear ideas about the richer and poorer parts of the heavens as viewed from Earth. In considering stars of the first 6 magnitudes only, stars visible to the naked eye, a somewhat larger number is found in the southern hemisphere than in the northern hemisphere. In both hemispheres, there are regions densely crowded with stars and regions, by comparison, almost empty. It has been long questioned whether the number of bright stars is or is not greater in the Milky Way than in other parts of the sky. Careful calculations have at length been made. It appears that the whole of the Milky Way, that zone of soft light passing round the earth, covers, If we leave out the coal sack and other such gaps, between 1/10 and 1/11 of the whole heavens. The entire number of naked-eye stars, or stars of the first 6 magnitudes, does not exceed 6,000, and of these 1,115 lie scattered along the bed of the Milky Way stream. If the brighter stars were scattered all over the sky as thickly as throughout the Milky Way, their number would amount to 12,000 instead of only 6,000. This shows us that the higher magnitude stars really are collected along the Milky Way in greater numbers than elsewhere. In the dark spaces of the Milky Way, on the contrary, bright stars are so few that if they were scattered in the same manner over all the sky, their present number of 6,000 would come down to 1,240, which would be a serious loss. No rest, no quiet, no repose in that great universe which to our dim eyesight looks so fixed and still, but one perpetual rush of moving suns and worlds. For every star has its own particular motion. Every sun is pressing forward in its own appointed path. And among the myriads of stars, bright blazing spheres of white or golden, red, blue, or green radiance, sweeping with steady rush through space, our sun also hastens onward. When I speak of the sun's movement, it must of course be understood that the earth and planets all travel with him, much as a great steamer on the sea might drag in his wake a number of little boats. From one of the little boats you could judge of the steamer's motion quite as well as if you were on the steamer itself. Astronomers judge partly of the sun's motion by watching the seeming backward drift of stars to the right and left of him. And the watching can be as well accomplished from Earth as from the sun himself. After all, this mode of judging is and must be very uncertain. Among the millions of stars visible, we know the distances, roughly, of less than 100, and every star has its own real motion, which has to be separated from the apparent change of position caused by the sun's advance. It seems now probable that the sun's course is directed more or less towards the neighborhood of the constellation Hercules. But if orbits of suns, like orbits of planets, are eclipses, he will curve away sideways long before he reaches Hercules. Another investigation gives a neighborhood of 61 Cygni as our next station. It is difficult to give any clear idea of the immensity of the universe, even of that portion of the universe which lies within reach of our most powerful telescopes. How far beyond such limits it may reach we lose ourselves in imagining. Earlier in the book, we have supposed possible models of the solar system, bringing down sun and worlds to a small size, yet keeping due proportions. What if we were to attempt to make a reduced model of the universe? That is, of just so much of it as comes within our ken. Suppose a man were to set himself to form such a model, including every star which has ever been seen. Let him have one tiny ball for the sun and another tiny ball for Alpha Centauri, and let him, as a beginning, set the two 1 yard apart. That single yard represents 91 millions of miles, 230,000 times repeated. Then let him arrange countless multitudes of other tiny balls at due distances, some 5 times, 10 times, 20 times, 50 times as far away from the sun as Alpha Centauri. It is said that the known universe, made upon a model of these proportions, would be many miles in length and breadth. But the model would appear fixed as marble, the sizes and distances of the stars being so enormously reduced, their rates of motion would be lessened in proportion. Long intervals of time would need to pass before the faintest motion of one of the millions of tiny balls could become visible to the human eye. End of section 26.